Hello guys, welcome to the chemistry or science paper 2 revision. So these are the questions which I gave you in the previous revision. These questions were posted in the WhatsApp group and then I asked you to answer so that I look at how you have understood so far chemistry so that you can help yourself to answer the questions and allow you to make as many errors as possible so that even as I go through your work, I'm able to notice the errors, and then as I mark through your work, I'm able to make correction on where you have made errors so that as you go in the examination there, you wouldn't have again to repeat the same errors. So we are going to go through these questions together. So this question here came in a paper which came in 2018. That's where I got this question. So the question was like, write your answers in the spaces provided on the answer paper. 1A, give 2 reasons why chemistry is important in industry. So you give 2 reasons why chemistry is important in industry. So the first reason could be that chemistry helps us to manufacture raw materials such as cement in the construction industry. So you can say chemistry helps us in the production of raw materials such as cement used in construction industry. Okay, so that is one way chemistry is important to us. Then you can also mention another way to say chemistry is important because it helps us to produce fertilizer, which is used in the agriculture industry. So you say chemistry helps in the production of fertilizer which is used in the agriculture industry. Okay, so there are many uses of chemistry, or there are many importances of chemistry. You can even say chemistry is important because it helps us to produce polymers which are used to make various products such as plastics. You can also say chemistry is important because it helps us to produce or process fuel which is used in the transportation industry. You can also say chemistry is important because it helps in the extraction of metals which are used in the construction industry. So there are so many ways chemistry is important to us, okay, or to industry. Then we move on to question B, which says state any laboratory safety rules. Again, there are many laboratory safety rules, so here they just wanted you to state 2. So you can state 1 to say never eat anything in the laboratory. Okay, so you say never eat anything while in the laboratory. Okay, while in the laboratory, you could also say always wear lab coat, laboratory. You wear laboratory coats, when carrying out experiments. In the laboratory. Okay, so there are many rules again, so you can revise on those. Okay, so then the other question here says, name the method of separation used in each of the following processes. Like you name the method of separation used in each of the following processes. Like A, to obtain liquid oxygen from liquid air. So how can you obtain liquid oxygen from liquid air? So in the first place, maybe someone may be confused to say, how can we have liquid oxygen? Is it the oxygen which is in the water? Is it the one being talked about as liquid oxygen here? No. Liquid oxygen is oxygen that has been formed due to compression and expansion of air. Or rather, I can say it is the oxygen that is formed when air is cooled. So when air, this normal air we breathe, if it gets cooled to very, very low temperature, it turns into air, or we can even say liquid air. We can have liquid air. So this liquid air now can have a lot of liquids in one mixture in liquid form, or a lot of air or a lot of gases which are going to be in liquid form in a mixture. So they will be in liquid form in the mixture. Like so far we know that air consists of oxygen, nitrogen, carbon dioxide, and even noble gases. So when you cool this air to a very low temperature, it can become liquid air. And all these gases which are in air will be in liquid form in that very mixture. So you can begin obtaining each component of that liquid mixture. If you want, you can obtain them, and that is how oxygen is formed in industry. So air is first cooled to very low temperature so that air becomes now liquid, and it will be a mixture of many gases. And then those gases again can now be separated one by one because they've got different boiling points. So when oxygen is in that liquid air there, like that, how can it be obtained from there? So to obtain liquid oxygen from liquid air, how can you do that? So oxygen can be obtained from liquid air by fractional distillation. So you can say by fractional distillation. So that's how it can be obtained, fractional distillation, where liquid now is heated so that each component can boil according to its own boiling point and collected separately. Okay, then B, we are told to say to obtain sodium chloride crystals from an aqueous solution of sodium chloride. Like if you have an aqueous solution of sodium, an aqueous solution of sodium chloride. How can you obtain sodium crystals? So you can do this by crystallization. So you can do this by crystallization. Okay, so you can mention crystallization. So, and crystallization involves heating to evaporate excess solution or water to saturation point, and then allowing the saturated solution to cool under normal temperature so that crystals can now be formed. So here, putting the answer as crystallization like that is perfect. Then C, to find out if certain food dyes are safe for human consumption. So to find out if certain food dyes are safe for human consumption, the method that we can use is actually chromatography. Okay, chromatography. Because chromatography can be used to identify even whether components of a mixture, it can help us to identify components of a mixture. It can also help us to tell whether a substance is pure or not. So in that area of telling us the component of a mixture, chromatography can be used to actually determine or find out if food dyes are safe for human consumption. Okay, especially if they want to determine a counterfeit product. Because, for instance, let's say a company produces Coca-Cola as we already know it, then another company imitates to begin producing Coca-Cola. And if in their manufacturing they have not used harmful free substances, then people who would take that Coca-Cola may die. So in that case, chromatography can be used to identify whether that particular Coca-Cola is original or it is not actually original. Okay, so D, to obtain ammonium chloride from a mixture of sand and ammonium chloride. So how can we obtain ammonium chloride from a mixture of sand and ammonium chloride? So when we look at ammonium chloride is also a soluble salt. It has two actually properties here. One, it is soluble, and again, it can undergo sublimation. So if you would want to obtain ammonium chloride from a mixture of sand, you can either use sublimation here. So you can either use sublimation. So sublimation. So you can either use sublimation, or you can in fact use filtration or filtration. And yeah, you can use filtration and crystallization. But I feel that the main answer would be sublimation here. Okay, so let's move to the next question. The next question is this one here. So this question was like, the figure below shows the magnesium ion in the ionic bonding in magnesium oxide. So the figure below shows the magnesium ion in the ionic bonding in magnesium oxide. Okay, so when magnesium bonds with oxygen, what is formed is magnesium oxide. And then in that very compound of magnesium oxide, that magnesium oxide will consist of two ions. There will be magnesium ion, okay, and then there will be oxygen ion. Okay, so there will be oxygen ion. So we are told that that magnesium ion will look like this, and that is true. That's how it is. Then question A says write the atomic number for magnesium. So atomic number for magnesium, if you were to go on the periodic table, you find that the symbol for magnesium is Mg. Here there will be a number 12, and here there will be a number 24. So this number 12 here represents what we call atomic number. Okay, always remember this one is atomic number, whilst this number here represents what? Atomic mass, or you can say relative atomic mass there. So if they say write down atomic number for magnesium, it is this number 12 here. So you can just write just 12 like that. Okay, then B, they're saying determine the valence of magnesium. So valence is the number of electrons that magnesium loses to become stable. The number of electrons that magnesium loses to become stable. So this magnesium here, this very atomic number can help us to know the number of electrons that magnesium loses. Okay, because as we know, as I've said already, that magnesium having 12 here, which is atomic number, 24 here, which is mass number, this 12, it is atomic number and as well as the number of electrons. So number of electrons in magnesium is also 12. And in making these electrons be arranged in shells, the first shell is supposed to have 2, then the second shell is supposed to have 8, then the third shell is supposed to have 2. Okay, so 2 plus 8 plus 2 equals 12. Okay, 12 electrons. Now each the first shell is supposed to be filled to occupy 2 electrons for it to be filled up. Then that is the first shell. Then the second shell is supposed to have 8 electrons for it to be filled up. Then the third shell is supposed to have either 8 electrons or 18 electrons for it to be filled up. So if an electron, a shell does not have the required number of electrons in its shell, it is either that number of electrons which it has, it is lost, or it gains more. For metals, they usually lose. So magnesium can lose these 2 electrons. And because it loses 2 electrons to become now 8, which is this magnesium here. This magnesium ion here has got a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have seen 2 in the first shell and 8 in the outer shell. So it lost these 2 electrons. That's why it formed a magnesium ion with charge of positive 2. So in terms of the question, determine the valence of magnesium, the valence of magnesium would be 2 like that. Okay, then question number C says write the chemical formula of the compound formed when magnesium reacts with chlorine gas. Okay, so when magnesium reacts with chlorine gas, so how do we actually find the formula here? So it is simple. So you write the symbol, because formulas are derived using chemical symbols of element. So on the periodic table, magnesium, the symbol is Mg. Okay, and then the valence, which is the number of electrons it loses, is actually 2 there. Okay, it loses 2. You put it as power there. Then chlorine, this one here, chlorine gas, the symbol on the periodic table is L, I mean capital C and small letter L, like that. Okay, so now in terms of valence, magnesium, if you go on the periodic table, you find that it is Cl. Here there's 17, which means that magnesium has got the number of electrons equal to 17. So how do these electrons sit in shells? They sit like this. The first shell will have 2, then the second shell will have 8, then the last shell will have 7. So this last shell having 7 electrons does not make this shell to be filled up. It's supposed to have either 8 or 18. So for it to make this shell to be filled up, it has to gain 1 more electron to make 8. So you add 1 more electron on chlorine so that this one becomes 8, so that chlorine can have 2, 8 and 8 there. Now this electron can come from chlorine, I mean magnesium. So because it gains 1 electron, then the valence is 1, so you put 1 there. Then you can cross the powers. They can be the powers. This one comes here, this one goes there, so that now you can write as magnesium like that. The 1 is here, then the chlorine, and the 2 is there. Now this one is not very important, so we ignore it. So then your formula becomes capital M like that, small letter G, and capital L, C, and the 2 there. So this one then becomes the formula for magnesium. Okay, so then we move on to question D, which says state any 2 physical properties of the compound formed in C. So like we state the physical compound of this compound in C, the compound in C is magnesium chloride. So magnesium chloride is an ionic compound. Being an ionic compound, we mean that it's the compound that is formed due to ionic bonding. Ionic bonding is a type of bonding which involves the transfer of electrons from metallic atoms to non-metallic atoms. Now, because the reaction between magnesium and chlorine is an ionic bonding type of bonding, then magnesium chloride will have the properties of those ionic compounds. So one of the properties of ionic compounds is that one, they actually have high melting points. Okay, you could say they have high melting. Let me say they have high melting points. So I could say melting points. So another one, you could say they have high boiling points. So they have high boiling points. Okay, so there are many. You can say they conduct electricity in molten state. You could say that they conduct electricity in molten state. You can say they are generally solids at room temperature. You can say they are non-volatile and flammable. So there are many actually physical properties. Then we come to this question here, which says a student carried out an experiment in which two gas jars were set up as shown. So this question came in 2015 there. So a student carried out an experiment in which two gas jars were set up as shown. So we have two gas jars, gas jar M and then gas jar N. So the gas jar N, which is the bottom gas jar, contains actually bromine gas, and this bromine gas actually has brown color. Let's see, bear in mind it is brown in color. Okay, very important concept there. So they are saying describe what was observed when the gas disk was removed. If this gas disk here, which is separating gas jar M, which just contains air, and then gas jar N, which contains bromine, if it is removed, there will be diffusion of gases of bromine from the bottom gas jar N to the gas jar M, and also there will be the movement of actually air from a gas jar M to gas jar N. So that movement is going to ensure that the appearance of gas jar M changes from colorless to brown due to movement of or due to diffusion of gas jar from due to diffusion of bromine gas from gas jar N to gas jar M. So we are going to say what will be observed is that the appearance, because observation is to use the eye when answering such question, it is to deal with the eye. So you say the appearance, okay, of gas jar N M changes, you can say from colorless to brown due to the diffusion. Due to the diffusion of bromine gas from gas jar N to gas jar M. Okay, this is the logical answer. Then they say explain why this change occurred. You can say this change occurred due to diffusion. This change occurred due to diffusion. Okay, so let's move to another question on page 3. So this question on page 3, which came in 2014 3, it says table 3.1 below shows the ions present in 1 liter of mineral water bottled for drinking by an industry. So table 3.1 below shows the ions present in 1 liter of mineral water bottled for drinking by an industry. Okay, so you have heard there's one bottle of mineral water, and in it contains these ions. Name of ion: there's calcium, chloride, bicarbonate, sodium, sulfate. Then formula of the ion, we have these formulas here. Then mass of ion present in 1 liter per milligram. So the masses are here. So this part here is actually concentration. Okay, then we go ahead to answer the questions. A says define the term ion. So we can say an ion is a charged atom or group of charged atoms. Okay, so that is the answer. That's how we can define an ion. Okay, then we come to B. They are saying identify the cation, the keyword the cation, with the lowest concentration in the mineral water. So the cation are positively charged ion. So they can ask you to define cation. Cations are positively charged ions. Okay, positively charged ions. That's what they are. Then we have also what we call anions. Anions, them are negatively charged ions. So, but the question was asking about cation. So we'll go for those ions that are positively charged. So we have this, which is calcium, and this one, which is sodium ion. So of these, the question says identify the cation with the lowest concentration. So the one which has a lower number in concentration. So when we look at calcium, it has 5, and then sodium, it has 3. So between 4 and 5, 4 is lower. So the ion or the cation with the lowest concentration is sodium ion. So here we can say sodium ion. Okay. Then we come to C, where they're saying complete the equation below to show how a calcium ion is formed from a calcium atom. So they're saying we complete this equation below to show how a calcium ion is formed from a calcium atom. So remember, for a calcium ion to be formed, calcium must have lost electrons. So if calcium formed this ion here of positive 2, it means calcium atom here lost 2 electrons. So it is those 2 electrons which we need to write here to complete. So you write like this, to the power negative. So this is a complete equation which they wanted you to come up with. Then we move on to question D, which says when this sample of mineral water is evaporated to dryness, various compounds remain as residues. Give the names of 2 of these compounds. So they're saying when these, let me read again. They're saying when this sample of mineral water is evaporated, when a sample of this mineral water is evaporated, they're saying to dryness, various compounds remain as residue. So which compounds will remain after water has evaporated? Because that's what they mean when they say those will remain as a residue. So those which will remain after the water has evaporated are compounds that will be formed, like there can be, these compounds will be formed between positive and negative. Okay, so you can come up with these by just combining positive, like you can have sodium chloride, okay, you can have also calcium, because we have calcium, so we can also have calcium sulfate. Okay, so these are the ones. Of course there can be more. Then either saying state the type of bonding found in the various compounds in the mineral water. So the type of bonding like found in these compounds like sodium chloride and calcium sulfate, the type of bonding is ionic bonding. So here you can say ionic bonding. Okay, then we move on to the next question, which is question number B1, which came in 2017. So this question says the diagram below shows the cooling curve for a liquid. So this one is a cooling curve. So for you to be able to understand what they mean by cooling curve, you just need to know the word cooling. Cooling is the process of removing heat from a substance. And if, for instance, they say cooling curve for water, it means a liquid, it means it is the liquid whose temperature is being reduced. Now, before you answer, you must understand that if a liquid, its temperature is reducing, what will happen to the liquid? It will begin changing from liquid to solid. It will change from liquid to solid. Okay, so in a liquid, in this cooling curve for a liquid, we expect change of state from liquid to solid. Okay, so it means that you are cooling a liquid, so your starting state, your starting substance is actually in the liquid. You have a liquid which you are cooling and it is in a liquid state. So you see, the cooling curve like this one or heating curve, they can have actually temperature on the vertical axis or y-axis and time on the horizontal axis, so to show the variation of temperature with the time. So now we need to analyze before we can even answer. So like you have a liquid, you begin cooling the liquid. So now it means that this liquid, it is at A, this position A here, you have a liquid. So in this area here, you have actually liquid here. Then this BC area, horizontal, this area, you have two. You have liquid and solid. Why? Because since you are removing, you are cooling the liquid. So this curve up to when it reaches B there, where the now line is horizontal, this signifies constant temperature. And when you have a horizontal line on the cooling curve, it means change of state. So it means that if at A you had liquid and then BC, which is horizontal line, which represents change of state. Then there's change of state from liquid to solid. That's why I've said B to C, it is liquid and solid. Then after C here, you see the graph again beginning dropping. Okay, it means the temperature reduces. So meaning that at D here, in this area now, we have just a solid D only because all the liquid has now changed into solid. And now this point here between B and C, it is in terms of process, that is freezing. But in terms of a point, we can call it freezing point. Okay. Now, if we go to this question, to these questions here, these questions are saying in what state of matter is the substance in area A? So in area A, the state of the substance is liquid. Okay. Then B, they're saying what name is given to the point labeled B? So the point labeled B here can be referred to as freezing point. Okay. Then, in what states of matter is the substance between points B and C? So between points B and C, this region here, I said it will be in solid, in liquid and solid. So you say liquid and solid. Okay. Then we come to D, where they're saying explain the reason why the thermometer reading remains constant between point B and C. So between point B and C already, we have already demonstrated or explained that between this point, the temperature is constant despite the liquid being cooled. So it means that there must be generation of heat. So we explain why the thermometer reading remained constant. So in short, you can say because there is change of state from liquid to solid, which is also generating some heat. So because there is change of state, change of state from liquid to solid. Then E, they are saying what happens, explain what happens during cooling in relation to the heat content of the substance. So during cooling, in short, what will happen to the heat of content of that substance? So you can see that when you are cooling something, the heat begins to decrease. So the heat content of the substance decreases. So when they say explain what happens during cooling in relation to the heat content of the substance, you can say that the heat content decreases. The heat content okay. Then we move on to the next question. Maybe this one will be the last, then the remaining part will be answered in the next lesson or revision. Then B3 says beryllium burns in fluorine to form a white solid, which is beryllium fluoride. Beryllium burns in fluoride to form a white solid, beryllium fluoride. Then they're saying A, name the type of bonding in beryllium fluoride. So the type of bonding in beryllium fluoride here is ionic bonding because it involves beryllium, which is a metal, and chlorine, which is non-metal. Okay, then we go to, so when they say name the type of bonding in beryllium fluoride, we can say this is ionic bonding. Then we go to B, which says in the space below, draw a dot and cross diagram to show the bonding in beryllium fluoride. Show all electrons. So for us to answer this question, we must be able to use the periodic table, where we should be able to know the number of electrons which beryllium has, and then the number of electrons which fluorine has. So let me just get the periodic table. So let's see if I can get the periodic table here. Okay, so I can have now the periodic table. Let me open it so that we can use it. And the good part is that the periodic table will always be provided in your exam. So beryllium is somewhere here, guys. This one here. So beryllium is actually Ba, and it has atomic number 4. It means it has 4 electrons. Then again, fluorine is somewhere here. It has atomic number 9, meaning it has 9 electrons. So now we know that fluorine, first beryllium, which is Be, has 4 electrons which sit as 2 and 2. Then fluorine has 9 electrons which sits in the first shell 2, in the second shell 7. So for both of these, you can see that their second shells are not stable. So for beryllium, the second shell is supposed to have 8, yet here it has just 2. So it is not stable. And also for fluorine, the second shell is supposed to have 8 electrons, yet it has only how many? 7 electrons. So it needs to gain 1 more electron to be stable. So what will happen is that beryllium, for it to be stable, it will lose these 2 electrons here, so that these 2 electrons come to fluorine. Now since fluorine just gains how many? 1. It means that here when beryllium loses 2, fluorine will gain only 1. So the 1 remaining here will go again to another fluorine. So there must be another fluorine that must be able to gain that electron here, so that here it will be 2, 8, and here 2, 8. Now in showing bonding, you do like this. You draw this one for fluorine. So fluorine will be 2. So this one, beryllium, will be 1. So you draw all the shells according to them. So for beryllium, you draw it has only 1 shell, like that. So you give it how many electrons? 2. 1, 2. So if you want, you can even put B here like that. Then you put these square brackets like that. So since it lost 2 electrons, you put 2 here and plus here. Then now you draw for fluorine 2 shells, like here 1, you put dots because they're saying you use dot and cross. So for fluorine F we are using dots for 2 electrons in the first shell, then we'll draw this one 8, so say 1 2 3 4 5 6 7 8. So you even do like this as well. Oh sorry, there's one mistake I've made. 1 electron here must be written as X, so that it shows that this one was not its original. So it gained 1, this one, you put a negative power there. Then you draw another one here, like F. It has 1 2, then the second shell you say 1 2 3 4 5 6 7 8. So even this one has that electron which it got, then you draw, you put like that. So these are the structures they are talking about when they say in the space below draw a dot and cross diagram to show the bonding in beryllium fluoride. Show all electrons. So we have shown. So this part here cannot be there. I've just used it to explain. You can just do it like the way it is without this part. So we move on to question C, where they're saying suggest any 2 physical properties of compounds that have similar bonding as beryllium. So compounds that have the similar bonding as beryllium are ionic compounds. And again, so we can say the 2 physical property is 1. We can say that they are insoluble in organic compounds. Yeah, you can say like that. Then if you want, you can say they conduct electricity in molten state. So they conduct electricity in molten state. Okay, then we move on to the next question, which says before Elena wanted to obtain clear water from mud water. Elena wanted to obtain clear water from mud water. A, name the process that the Elena would use to obtain the clear water. So the process the Elena would use, if you have, for instance, mud water, water with mud, how can you obtain clear water from that water? You can use filtration. So you say filtration. Then B, they're saying draw a large labeled diagram to show the arrangement of the apparatus the learner would use. So like you draw a large diagram to show filtration. So here what you can show, you can just draw a beaker, or first you can draw a funnel. Okay, then you can, if you want this funnel, okay, let me do it this way. I think this way I'm going to show is the best way. You can have a clamp stand, you draw very nicely. So this clamp stand will hold so here under the clamp stand there'll be a filter funnel there. Then below it, if you want, you can put now a beaker. So this is the diagram they wanted. You put a beaker, then here you can also put a beaker like that. So this beaker has got the materials coming here. You can do like this to show that there are materials there. Okay. Then you can show to my drops like this. Then you show like that. Then here you can even do like this. So here you can say, okay, here there'll be even a paper. So you can say funnel plus filter paper. You can say funnel and the filter paper. Then here you can say this is clean water, then here there will be mud which will remain. Then here you can say mud water. Okay. Yeah, so this one will be mud water. Then if you want, you can say this one is a clamp stand. Yeah, just like that, then you are done with your arrangement. Then we move on to see where they're saying give an industrial application of the process named in B above. So it is used in the filtration of water. So this one is used in filtration of water. So it is used in the you can say even in the purification of water. Okay, so I'm ending here so that the video will not be very long. So let's end here. The next part of the video will be completed in the next video. For now guys, bye and see you in the next video.